Naga Arjuna was the most significant Buddhist philosopher of India. He was the founder of the middle way school, Madhyamaka, which is of great topical interest because it became fundamental to all later Buddhist scholarly thought, known as Mahayana, the Great Vehicle. Naga Arjuna's main work, Mula Madhyamaka Karika, has been translated into several European languages. To avoid wrong pronunciation of Mula Madhyamaka Karika, we will use MMK short form as substitute for Mula Madhyamaka Karika. A brief review of the 25 chapters of the Mula Madhyamaka Karika MMK. Chapter 1. A thing and its cause. Let's see an example. A arrow after penetrating a target, consider it an apple. The penetration of the arrow is the cause of the direct effect, the beginning of an explosion of the apple. This happens at the same moment. Cause and effect cannot be separated. They are not one object and they are not two separated objects. There is no space and no time between cause and object. The cause leads immediately to a near effect. There is not first a cause and later an effect. The most important characteristic of bodies is their interdependence and the resultant, substancelessness, the impossibility of existing individually and independently. A thing is not independent of its cause and conditions, nor is it identical with them. Chapter 2. A mover and the distance to be moved. Let's see an example. A thing is not independent of its conditions, nor is it identical with them. A mover does not exist without the distance within which to move. The mover and the distance are not one. A mover and the distance are neither together nor separated. The most important characteristic of bodies is their interdependence and the resultant, substancelessness, the impossibility of existing individually and independently. Chapter 3. A seer and a vision of you. Chapter 4. A cause and its effect. Chapter 5. A characteristic and its characterization. Chapter 6. Desire and the desirous one. Chapter 7. Origination, duration and decay. Chapter 8. Action and agent. When there is no action there is no agent, neither exists per se. Action and agent are not isolated components, they arise only by their dependence on other bodies. Not the behavior of bodies but the behavior of something between them is essential. Chapter 9. A viewer and a vision. Chapter 10. Fire and fuel. Without fire there can be nothing designated as fuel. The material or immaterial components of a two-body or three-body system do not exist in isolation, they are not one and yet they are not independent of each other. Something is happening between these bodies and because of this, they are not substantially real. Naga Arjuna emphasizes one central idea: bodies are neither together nor separated. The most important characteristic of bodies is their interdependence and the resultant, substancelessness, the impossibility of an independent and individual existence. Chapter 11. Birth and Death. Chapter 12. Suffering and the causes of suffering. Suffering is not independent from a cause of suffering and not identical with its cause. There can be no cause without an effect, or an effect without a cause. The notion cause has no meaning without the notion effect. Cause and effect are not one, but they cannot be separated into two independent notions either. Like suffering, reality does not consist of single, isolated material or immaterial components. Suffering arises only by dependence on other causes. Like everything in this world, suffering and its cause are not one and they are not two different objects. Chapter 13. A teenager and an aged person. When you are old, before some years same person was young. These two persons are not the same and they are not two different men. Chapter 14. Something in a different thing. Chapter 15. Being and nothing. Chapter 16. Bondage and liberation. There is no liberation without bondage. For two complementary realities, bondage and liberation, the nature and the existence of each are dependent on the other. There is no fundamental core to reality, rather reality consists of systems of interacting facts or ideas. Chapter 17. Action and its fruit. Chapter 18. Identity and difference. Chapter 19. The past, the present and the future. Chapter 20. Cause and effect. Chapter 21. Coming to be and passing away. Chapter 22. The Buddha exists and the Buddha does not exist after death. Chapter 23. Pure and impure. Usually two waters get mixed when they come together. These two impure waters remain separated in the same river at the beginning of the two rivers. Only after 30 kilometers they are completely mixed. The idea or notion, pure, has no meaning without the opposite idea or notion, impure. A fundamental or elementary or independent idea or notion does not exist. Our ideas or notions are dependent. One notion is contingent upon another. If the Son is produced by the Father, but the Father also produced by that very Son, then will you please tell me, which one is the true cause, and which the true result? Chapter 24, Buddha and Bodhi. Chapter 25, Nirvana and Being. Naga Arjuna emphasizes one central idea: bodies are neither together nor separated. The most important characteristic of bodies is their interdependence and the resultant, substancelessness, the impossibility of existing individually and independently. This is the meaning of pratityasamutapada and shunyata. Bodies are without own being and are not independent of each other. Reality does not consist of single, isolated material or immaterial components. It is not the behavior of independent bodies but the behavior of something between them that is essential. Let us concentrate on the 25 chapters. A thing is not independent of its conditions, nor is it identical with them. A mover does not exist without the distance within which to move. The mover and the distance are not one. A viewer is not the same as the view, but a viewer without a view does not exist. There can be no cause without an effect, or an effect without a cause. The notion cause has no meaning without the notion effect. Cause and effect are not one, but they cannot be separated into two independent notions either. Without a characteristic, we cannot speak of a characterization, and the other way round. How could there be a desirous one without desire? When there is no action, there is no agent, neither exists per se. Without fire, there can be nothing designated as fuel. The material or immaterial components of a two-body or three-body system do not exist in isolation. They are not one and yet they are not independent of each other. Something is happening between these bodies and because of this they are not substantially real. For two or sometimes three complementary bodies or for two concepts like cause and effect, or bondage and liberation, the nature and the existence of each are dependent on the other. The one arises with the other and disappears with the other. This is why a thing arises substantially, neither out of itself, nor out of another, nor out of both, nor without a cause. There is no fundamental core to reality, rather reality consists of systems of interacting bodies. This view of reality is first and foremost an idea, a pointer to reality which cannot be described in words. One who can speak about concept-free reality has not experienced it. For the Buddhist tradition based on Naga Arjuna, the yogic experience of substancelessness, the experience of dependent arising, the direct perception of reality as it is, all presuppose a high level of spiritual realization which entails the abandonment of extreme views and the demolition of the entire edifice of dualistic thought and philosophy. To experience pratityasamutapada or shunyata means to become free of all entanglements of this world. Nirvana is simply another expression for this. For Naga Arjuna, the primary question was not about mind, nor about the origin of knowledge but about the reality of the physical world. Everything existing partakes in a fundamental, mind field, which is the basic substance, from which mind in a more individual way and the individual body develop. In order to emphasize that Naga Arjuna does not only speak about views without substance but also about bodies without substance, here is a comparison with the views of reality suggested by quantum physicists. Physics is about views and the conditions of physical reality. It creates models and thus examines only realities which have been posited by physics itself. Nevertheless, as the experimental psychologist Irwin Rock, who studied visual perception, describes it, we should not go so far as to consider all our perceptions and thought models to be purely adventitious. While the constructions of our mind are not identical with reality, they are not purely coincidental and usually not deceptive. Behind these models are empirical bodies and there is some approximation of a structural similarity between a physical model and the corresponding physical and tangible reality. In the middle way doctrine of Buddhism, it is described as pratityasamutapada. What arises dependently is pronounced to be substancelessness. This is nothing but a dependent concept. Substancelessness or shunyata constitutes the middle way. Naga Arjuna's view consists principally of two aspects. The first is an exposition of his view of reality, according to which reality has no firm core and does not consist of independent, substantial components. Reality is rather a system of two bodies or many bodies which reciprocally affect each other. This view of reality is diametrically opposed to another key concept, swabhava, own being, or inherent existence, also known in the Greek tradition as substance. Nagarjuna's interpretation Madhyam Marga, which is middle path, was in a liberation which avoids the extreme views of substantialism and subjectivism. Then question is what Nagarjuna means substantialism and subjectivism. Let's understand substantialism. Substance or own being is defined as something that has independent existence. Substantialism is at the center of traditional metaphysics, beginning with pre-Socratic philosophers, for example Parmenides and Heraclitus, who were two critics of substantial thought, and going right up to Immanuel Kant. Substance is considered to exist by itself, i.e. the unchangeable, eternal and underlying basis for the entire non-material foundation of the world in which we live. Plato in 4th century BCE made a distinction between two forms of being in his Parmenides. On the one hand, singular objects which exist exclusively through participation without own being, and, on the other hand, ideas that do have own being. Traditional metaphysics adopted Plato's dualism. An independent own being is characterized as something that, as an existing thing, is not dependent on anything else, as existing by itself and subsisting through itself, is completely unlimited by others and free from any kind of foreign command, which he called Spinoza, and exists of itself without anything else shelling. The highest substance was often understood as God. Since Kant's Copernican revolution, the primary question of philosophy has no longer been to comprehend reality, but rather to fathom the mind. For this reason, traditional metaphysics has lost ground in the modern world. In fact, its central concepts, such as substance, reality, essence, and being, have been replaced by the reductionist modes of thought of modern science. Now, atoms, elementary particles, energy, fields of force, and other concepts derived from the laws of nature are viewed as the fundamental ground. Now let's understand what is subjectivism. Subjectivism is the philosophical theory that all knowledge is subjective and relative. According to René Descartes, consciousness is primarily existent and everything else is sheer content of form, a creation of consciousness. The subjectivism of Immanuel Kant can be considered as moderated idealism. Hans-Georg Gadamer emphasizes that subjectivity, self-awareness, has become the fulcrum of modern philosophical thought, which provides us with evidential proof and certainty. This view has been continually brought into doubt by modern physical science. However, these doubts have not led to a new view of reality but to a fatal separation of philosophy and the sciences. This separation has exacerbated the dualism that preoccupies modern thought. Accordingly, the physicist P.C.W. Davies expounds in his 1986 book that electrons, photons or atoms do not exist, they are nothing but models of thought. Nagarjuna presents these four extreme views of reality in a scheme that is called in Sanskrit, Kataskoti, the equivalent of the ancient Greek, tetralemma, as follows: things have no substance, 1. Neither out of themselves, 2. Nor out of something else, 3. Nor out of both, 4. Nor without a cause. In the very first verse of the MMK tetralemma is pointed out, neither from itself nor from another, nor from both, nor without a cause, does anything whatever anywhere arise. This verse can be understood as the principal statement of the MMK, the refutation of the four extreme metaphysical views which cannot be reconciled with the dependent arising of things. If this is the case, the remainder of the MMK would be a clarification of this verse. This requires careful examination. What is the assertion made by this verse? That nothing can be found, that there is nothing, that nothing exists. Was Nagarjuna denying the external world? Did he wish to refute what evidently is? Did he want to call into question the world in which we live? Did he wish to deny the everywhere presence of things that somehow arise? If "to arise" refers to the empirical data, then we are obliged to argue that if a thing does not arise out of itself, it must arise out of something else. So we should ask, what is the significance of the notion, to arise? In another text, Nagarjuna gives some indications how to understand this view. He writes in his Yukti Sastika, That which has arisen dependently on this and that has not arisen substantially, in Sanskrit called swabhavata. What has not arisen substantially, how can it literally be called arisen? That which originates due to a cause and does not abide without certain conditions but disappears when the conditions are absent, how can it be understood as to exist? By the notions of to arise and to exist, Naga Arjuna does not mean the empirical existence but the substantial existence. They do not exist out of themselves, their independence cannot be found. They are dependent, and in this sense they are substantially unreal. Naga Arjuna only rejects the idea of a substantial arising of things which bear an absolute and independent existence. He does not refute the empirical existence of things as explained in the following. It exists implies grasping after eternity. It does not exist implies the philosophy of annihilation. Therefore, a discerning person should not decide on either existence or non-existence. MMK Chapter 15, Verse 10. For Naga Arjuna, the expression to exist has the meaning of to exist substantially. His issue is not the empirical existence of things but the conception of a permanent thing, i.e. the idea of a known being, without dependence on something else. Naga Arjuna refutes the concept of independent existence which is unchangeable, eternal and existing by itself. Things do not arise out of themselves, they do not exist absolutely and are dependent. Their permanent being or existence cannot be found. The many interpretations of Naga Arjuna which claim that he is also refuting the empirical existence of objects are making an inadmissible generalization which moves Naga Arjuna near to subjectivism, nihilism and instrumentalism. Such interpretations originate in metaphysical approaches which themselves have a difficulty in recognizing the empirical existence of the data presented. This is not at all the case with Naga Arjuna. The metaphysical foundations of quantum physics. The views of reality in quantum physics can be expressed by three key terms: complementarity, four interactions and entanglement. In the prehistory of quantum physics, it could not be proved experimentally whether the smallest elements of light were particles or waves. In the prehistory of quantum physics, it could not be proved experimentally whether the smallest elements of light were particles or waves. Many experiments argued in favor of one or the other assumption. Electrons and photons sometimes act like waves and sometimes like particles. This behavior was named wave-particle dualism. The idea of dualism was therein understood to be a logical contradiction, in the sense that only one or the other could actually apply, but paradoxically both appeared. According to this understanding of atomic theory, electrons and photons cannot be both particles and waves. According to atomic theory, a scientific explanation consists of a reduction of a variable factor into its permanent components and their applicable mathematical laws. This is the fundamental dualistic view that modern atomic theory has inherited from the natural philosophy of the ancient Greeks, who expounded that substance and permanence cannot be found in objects of perception of the world in which we live, but can be found in the fundamental elements making up objects and their mathematical order. These material and immaterial foundations hold the world together, they do not change, although everything else changes. According to the expectation of atomic theory, it should be possible to reduce an object to its independent elements, to its mathematical laws, or to its simple and fundamental principles. Until 1927, the fundamental elements had to be either particles or waves, they could not be both. What is to be understood by independent elements? As mentioned before, the notion of substance refers to something that has independent existence. Albert Einstein's contribution to the interpretation of quantum physics. Albert Einstein was following the aforementioned metaphysical tradition when he wrote in the year of 1948 very clearly, "For the classification of things that are introduced in physics, it is essential that these things have for a certain time an independent existence from each other, insofar as these things lie in different parts of space." Without the assumption of such an independent existence, Einstein uses the German term so sein. This is akin to terms like substance, or being, or suckness of things which, in terms of ordinary thought, are spatially distant from each other. Physical thought in the usual sense would not be possible. This idea of an independent reality was projected onto the basic element of the world of matter by atomic theory. For atomic theory, a scientific explanation means to reduce the variability and variety of objects and conditions to their permanent, stable, independent, and indivisible elements and to their conformity with mathematical laws. According to the expectations of atomic theory, all variations in nature can be explained in terms of separation, association and movements of unchanging, independent atoms or still more elementary particles. These particles and their conformity to mathematical laws constitute the core of bodies. They underlie everything and hold the world together. The question whether the fundamental objects are waves or particles was an explosive issue, at stake with the traditional metaphysical views of reality available to quantum physics. It became evident that fundamental reality could not be grasped by traditional views of reality. What is the explanatory value of atomic theory if it becomes clear that there are no independent, stable atoms or elementary particles, and that objects have no stable core? Are these quantum objects objective, subjective, both or neither? What is reality? Is the quantum world completely distinct from the world in which we live? Niels Bohr's contribution to the interpretation of quantum physics in 1927, the physicist Niels Bohr introduced the idea of complementarity into quantum physics. According to this idea, the wave form and the particle form are not two separate forms which contradict and exclude each other but are mutually complementary forms which can provide a complete description of physical manifestations only together. According to Niels Bohr, complementarity means that in the quantum world it is impossible to speak about independent quantum objects because they are in an interactive relationship with each other as well as with the instrument of measurement. He emphasized that this interaction between the quantum object and the instrument of measurement was an inseparable element of quantum objects, because it plays a major part in the development of several features of them. Certain measurements establish electrons or photons as particles and destroy the interference that distinguishes the object as a wave. Other measurements establish the object as a wave. This was Niels Bohr's new idea of reality. From the insight that the quantum object and the instrument of measurement could not be separated, Niels Bohr did not conclude that there are no quantum objects. At least he did not do so when he was arguing in terms of physics. When he spoke about the metaphysics of quantum physics, he took an instrumentalist approach. For the physicist Niels Bohr, quantum physical objects consist of interacting and complementary quantum objects. The double slit experiment. See previous page. If you send an atom of helium through a double slit, every atom produces a point behind the double slit. The atoms arrive in discrete lumps. There is no interference in the beginning. The atoms arrive like bullets at the screen. But later they show interference. Their appearance shows the structure of waves in a similar manner to waves on water. The 7 pictures shown were taken at intervals ranging from 5 minutes to 42 hours and 18 minutes. Quantum objects show a double quality of particles and of waves. They are dependent on the instrument of measurement, the double slit. This double quality has been named complementarity by Niels Bohr. Complementarity means that the two qualities are not dualistic. They do not exclude each other but complement each other like the poles of a dipole. The concepts of interactions in the standard model of quantum physics. The notion of 4 elementary interactions was introduced in the standard model of quantum physics. These 4 forces obstruct the reduction of quantum objects into independent objects. Such an idea had already been posited by Democritus in the 3rd century BCE. The interactional forces which operate between the quantum objects are added to the quantum objects. Instead of singular, independent objects, 2 body systems or many body systems were established as the base of matter. Between the bodies, interacting forces are effective in keeping them together. These interactions are a composite of the bodies. Mostly they are forces of attraction, and in the case of electromagnetic forces they can also be forces of repulsion. One visualizes the interaction between the elementary particles as an interaction of elementary particles. The physicist Steven Weinberg puts it like this: at the present moment the closest we can come to a unified view of nature is a description in terms of elementary particles and their mutual interactions. The most familiar are gravitation and electromagnetism, which, because of their long range, are experienced in the everyday world. Gravity holds our feet on the ground and the planets in their orbits. Electromagnetic interactions of electrons and atomic nuclei are responsible for all the familiar chemical and physical properties of ordinary solids, liquids and gases. Next, both in range and familiarity, are the strong interactions which hold protons and neutrons together in the atomic nucleus. The strong forces are limited in range to about 10 to 13 cm and so are quite insignificant in ordinary life, or even in the scale 10 to 8 cm of the atom. Least familiar are the weak interactions. They are of such short range, less than 10 to 15 cm, and are so weak that they do not seem to play a role in holding anything together. In this respect, the explanations enter into quite difficult and subtle particulars. How, for example, can an electron which consists only of one particle be in interaction with another quantum object? What part of itself can it emit if it consists only of one particle? These questions can be answered by the concept of interaction. In fact, an electron does not exist of only a single particle exactly because the interaction of the electron is a part of it. In 1978, the physicists Daniel Z. Friedman and Peter van Nieuwenhuizen wrote in this regard that the observed electron mass is the sum of the bare mass and the self-energy, resulting from the interaction of the electron with its own electromagnetic field. Only the sum of the two terms is observable. What in quantum physics is known about interactions is here summarized in the words of the physicist and Nobel Prize laureate Gerard T. Hooft. An electron is surrounded by a cloud of virtual particles, which it continually emits and absorbs. This cloud does not consist of photons only, but also of pairs of charged particles, for example electrons and their antiparticles, the positrons. Even a quark is surrounded by a cloud of gluons and pairs of quark and anti-quark. Singular, isolated, independent quarks, a phenomenon which is called confinement, in recent research, have never been observed. Quarks are captives, they cannot appear on their own but only as one of a pair or as one of a trio. When you try to separate two quarks by force, new quarks will appear between them which combine into pairs and trios. Claudio Rebbe and other physicists have reported that, between the quarks and gluons inside an elementary particle, additional quarks and gluons are continuously formed and after a short time again subside. These clouds of virtual particles represent or produce interactions. The central core of quantum physics consists of a new view of reality that no longer perceives singular, independent elements but rather two body systems, two states of a quantum object or two concepts, e.g., Earth-Moon, proton-electron, proton-neutron, quark-anti-quark, wave-measuring instrument, particle-measuring instrument, twin photons, superpositions, spin-up, spin-down, matter-antimatter, elementary particle, field of force, law of nature, matter, etc. These systems cannot be separated into independent parts, or reduced to two separate, independent bodies or states, nor as one fundamental and the other derived, as the metaphysical either-or schemes of substantialism and subjectivism try to establish. They are not joined into a seamless unity either, they are not the same, they are not identical, and they are not a mysterious wholeness as holism indicates. Finally, we cannot claim, as instrumentalists do, that they are nothing but mathematical models which we have constructed and which do not correspond to physical reality. In physics, there is a fundamental reality that is not a one-body system. It is a two-body system or an assembly of bodies, a cloud of virtual particles which surround the central or naked body. Between these bodies is an interaction that is one of the composites of them. This understanding of physics cannot be dislodged, and yet all our metaphysical schemata struggle against it. The cloud does not conform to our traditional expectations of what should delineate and underpin stability, substantiality and order. How can clouds be what we are used to calling the basic elements of matter? How can this small vibrating something be what generations of philosophers and physicists have been searching for in order to arrive at the core of matter, the ultimate reality? Is this supposed to be it? From these little clouds we attempt to use metaphysical interpretation to distill something that has substance and is enduring. Entirely within the sense of the substance metaphysics of Plato, Heisenberg 1901–1976 contends that the mathematical forms are the idea of elementary particles and that the object of elementary particles corresponds with this mathematical idea. The physicist and philosopher Carl Friedrich von Weizsäcker 1912–2007 called mathematics the essence of nature. According to the physicist's Copper, fields of force are the ultimate reality. Some of us want to see reality as a mysterious whole, holism, or dismiss it as a construction without any correspondence to empirical reality, instrumentalism. All of this only because we do not find it easy to admit that the complex interactions of the world in which we live have their roots in a reality that is in itself complex. It is impossible to escape from the entanglement of this world in quantum physics and to find an elementary quantum object that is not dependent on other quantum objects or on parts of itself. It is also impossible to dissolve the double-sided character of quantum objects. The fundamental reality of our physical world consists of clouds of interacting quantum objects. Conclusion. It seems that reality is not static, solid or independent and does not consist of singular, isolated material or immaterial factors but of systems of dependent bodies. Most systems consist of more than two bodies, but there is no system that consists of less than two bodies. In quantum physics we call such fundamental two-body systems Earth-Moon, electron-positron, quark, anti-quark, particle field, etc. Naga Arjuna calls his systems or dependent pairs, move at distance to move within, fire, fuel, agent, action, view, etc. Both quantum physicists and Naga Arjuna deal with two-body systems or two entities which have bodies that are neither properly separate, nor properly joined together. They do not unite into one, nor do they fall apart. These bodies are not independent and cannot be observed singly because in their very existence and constitution they are dependent on each other and cannot exist or function independently. They are entangled by interactions, even at a far distance. One of them cannot be reduced to the other and it is not possible to explain one of them on the basis of the other. The resultant systems have a fragile stability, the components of which are maintained by interactions and mutual dependencies which are sometimes known, sometimes not fully known and sometimes totally unknown, for example as with entangled twin photons. What is reality? We have become accustomed to believe in a firm ground under our feet and fleeting clouds above in the sky. The view of reality in Naga Arjuna's thought and the ideas of complementarity, interactions and entanglement of quantum physics teach us that everything is built on sand. Moreover, even the grains of sand are not endowed with a solid nucleus. Their stability is based on balancing unstable interactions of their components. Meanings of pratityasamutapada. In the first place, pratityasamutapada is an indication of dependence. Dependent bodies are in an intermediate state, they are not properly separated and they are not one entity. Secondly, they rely on each other and are influenced or determined by something else. Thirdly, their behavior is influenced by something in between, for example a mover is attracted by gravitational force, a viewer is dependent on rays of light between his eyes and the object, a piano player's action is determined by the fine motor skills of his fingers, an agent is dependent on his act. Pratityasamutapada is an indication of dependence and of something that happens between the objects. One object is bound to the other without being identical to it. The implicit interpretations of pratityasamutapada are in terms of time, structure and space. The following citations and references illustrate the term pratityasamutapada. Pratityasamutapada is used, 1. As dependence in Naga Arjuna's hymn to the Buddha. Dialecticians maintain that suffering is created by itself, created by someone else, created by both or without a cause, but you have stated that it is dependently born. 2. As an intermediate state by Naga Arjuna, objects are neither together nor separated. Naga Arjuna in 6 Myanmar Kyats. Thus. 3. As bondage in the Havajra Tantra, men are bound by the bondage of existence and are liberated by understanding the nature of existence. 4. As an intermediate state by Roger Penrose, quantum entanglement is a very strange type of thing. It is somewhere between objects being separate and being in communication with each other. 5. As something between bodies by Albert Einstein, a courageous scientific imagination was needed to realize fully that not the behavior of bodies, but the behavior of something between them, that is, the field, may be essential for ordering and understanding events. 6. As the mean between things in modern mathematics, to quote Gioberti again, the mean between two or more things, their juncture, union, transit, passage, crossing, interval, distance, bond and contact, all these are mysterious, for they are rooted in the continuum, in the infinite. The interval that runs between one idea and another, one thing and another, is infinite, and can only be surpassed by the creative act. This is why the dynamic moment and dialectic concept of the mean are no less mysterious than those of the beginning and the end. The mean is a union of two diverse and opposite things in a unity. It is an essentially dialectic concept, and involves an apparent contradiction, namely, the identity of the one and the many, of the same and the diverse. This unity is simple and composite, it is unity in synthesis and harmony. It shares in two extremes without being one or the other. It is the continuum, and therefore the infinite. Now, the infinite identically uniting contraries clarifies the nature of the interval. In motion, in time, in space, in concepts, the discrete is easy to grasp because it is finite. The continuum and the interval are mysterious because they are infinite. What is quantum entanglement? Two very short answers. According to Clegg, entanglement is a strange feature of quantum physics, the science of the very small. It's possible to link together two quantum particles, photons of light or atoms, for example, in a special way that makes them effectively two parts of the same entity. You can then separate them as far as you like, and the change in one is instantly reflected in the other. This odd, faster-than-light link is a fundamental aspect of quantum science. Schrödinger, who came up with the name entanglement, called it the characteristic trait of quantum mechanics. Entanglement is fascinating in its own right, but what makes it really special are dramatic practical applications that have become apparent in the last few years. According to Merrily, this weird quantum effect inextricably links two or more objects in such a way that measurements carried out on one immediately change the properties of its partners, no matter how far apart they are. Quantum effects, such as entanglement, are usually confined to the invisible microscopic world and are detected only indirectly using precision instruments.